Assalamualaikum. My name is Abir Drubo. I, along with my presentation partner Azimusshan Mahir, are here to discuss about the synthesis, characterization, and application of copper oxide nanomaterial. First of all, the question arises: what is a nanomaterial? A nanomaterial is a material which possesses one physical dimension from 1 to 100 nanometer scale. Mm. Nanomaterials have distinct properties and better physical properties than physical, chemical, and biological properties than their bulk counterparts. These enhanced physical, chemical, and biological properties are due to the quantum effect and increased surface to volume ratio. Now, in this discussion, we are going to discuss about copper oxide nanoparticle. Copper oxide nanostructure are of particular interest because of their increase in these properties and promising applications in batteries, supercapacitor, and gas sensors and superhydrophobic surfaces and many more. Moreover, copper oxide have a good antibacterial properties which is very effective against bacteria and bacteria, yeast, and fungi. Mhm. Nanomaterials can exist naturally or can be synthesized artificially through chemical reactions. Numerous methods have been recently developed to synthesize and various copper oxide nanostructures. In this study, we are going to discuss about the synthesis method of preparing stable copper oxide nanoparticle suspensions. In this method, suspensions diverse in copper oxide nanoparticles are prepared by an alkothermal method in which copper-2-acetate is reacted with sodium hydroxide at 78 degrees Celsius. The reaction is performed for 1 hour. This reaction is performed in 1 hour in different molar ratios of the starting material, and this can be shown in table 1. For the thin film fabrication, the preparation particles are washed and centrifuged 5 times with ethanol to remove byproduct sodium acetate. Remove byproduct sodium acetate. From the figure 1 the transmission electron microscopy image of copper oxide nanoparticle is directly deposited from the suspension. Now I would request my presentation partner Azimusshan Mahir to continue.
Thanks Abir Khan Drubo for presenting his presentation. I am Azimusshan Mahir. Now I will present the remaining half of the presentation. In figure 2, we are seeing 4 absorption ranges. First one at 532 cm inverse 1. Without any hesitation, declares that the achieved nanoparticle is copper oxide, as absorption at this level happens due to bond between copper and oxygen. Next, broadband absorption between 3200 cm inverse 1 to 3550 cm inverse 1 indicates OH bond stretching. We all know metals form coordination bonds with water. Here, copper made a coordination bond with water, and hydroxyl bond in water are resulting absorption at this level. In this range, water molecules absorb only. Another 2 sharp peaks are there at 1410 and 1564 centimeter inverse 1. This indicates carbon oxygen bond due to carboxylate ion added to copper oxide through coordination bond. In the X-ray diffraction analysis at figure 3, Debye-Scherrer equation indicates small size of the nanoparticle based on the peaks. Here, peaks are sharp, intensities are very high, peaks are regular too. So it is sure that the nanoparticle is crystalline in nature. In TEM image analysis, mean diameter has been found to be 5 to 8 nanometer. That's aligned with the X-ray diffraction provided diameter. So it is provided from both analysis that the mean diameter is between 5 to 8 nanometer. However, in UV visible spectrum, At figure 5, absorption peak is at 290 nanometer and absorption is at 426 nanometer. Corresponding band gap is 2.36 electron volt, which aligns with the copper oxide nanometer band gap at this level. The band gap is way higher than the bulk band gap of 1.85 electron volt. However, due to higher band gap, the synthesized nanoparticle can be used in dye-sensitized solar cell as p-type metal oxide uh, layer used for better absorption. Its band gap its band gap is higher than its bulk, making it comparatively a better choice for this cut for future uses. Another noticeable thing is blue shift behavior is also found in copper oxide nanoparticle due to quantum confinement, making it a unique choice than its bulk counterpart. However, copper oxide is of low cost, high solar absorbance, low thermal emittance, non-toxic, simple manufacturing process of it is also available, excellent stability, good electrical properties, and high carrier concentration in copper oxide nanoparticle, making it a good choice for many of the applications both in industries and in other fields. In figure 7, we are seeing the current density versus voltage graph for dye-sensitized solar cell incorporating zinc oxide copper oxide layer as photoelectrode. Here, copper oxide thin film exhibits much higher current density and power conversion efficiency. It prevents electron from reverse transferring, resulting in less energy wasting due to interfacial recombination. Here are the references we have used in this presentation, as well as the paper we have written. This is the references. Thank you.